So today my talk is about, largely is actually our journey when we started building from ground zero, and how we raise a monolith mammoth, and then after that our teams how we skin it and move into something more manageable, extendables, and to power our products. So I think first start a bit introduction about myself. I started with engineering like shy 50 years ago. So I started off more on the kind of like embedded system part of things. So do a bit of kind of like things on the microchip and microprocessors. Touch very slight on. Then when I move off kind of above it, the stack I do mainly on the networking software and embedded printers. Then move a bit to some applications on the webs. About 7 years ago, I joined an amazing group of people, and we mainly work around building marketplaces in the regions in Southeast Asia. So 6 years ago, after some work, we launched Chapter.com in Vietnam. Actually, back then it was started from Singapore in the stealth mode. And we, after 1 year, we landed in Vietnam, and from now it's our 6 years in Vietnam. So before I start the journey, maybe I'll get a chance to also share a bit on the backgrounds, the business backgrounds, to set the stage for our problems that we go about solving. It's the context, and I promise this is just about the background of it and should be nothing else. And also a bit on the PR, since Chapter is sponsor the event. I'm trying to share what we do. So basically we build online marketplaces for people to buy and sell, everyone to buy and sell largely. And in Vietnam, we are now the most well-known and favorite marketplace to buy and sell used items, and especially cars and motorbikes. This is like from Nielsen's for this year. And in terms of numbers and loads, we are serving 0.3 million visits daily, and we have about 1.2 billion page view on a monthly basis. Last year, just the items sold on our site is 3.3 billion. There's still a lot of items unsold on site, but yes, it's the not so super big numbers, but I think we are happy to have sizable loads to our systems. So apart from Chatbot, actually we do run other marketplaces in the regions, and we have Muda, which is the largest site in Malaysia, and we do also have Myanmar, our site called OneChat. So in terms of functionalities that as a tech system that power for the users, we provide service across webs and native apps with pretty much all the marketplace functionalities that you would say people both sales, and then we'll do auto moderations of that, plus a system for our 100+ reviewers of content to actually vet through the content before it's up there on our site, to make sure the safetiness of all these items for sales. And obviously, for sellers, we provide a set of premium services and all the payment channels that you can top up your credit onto our systems. And for property shops, electronic subscriptions for the pro sellers, people can buy its display ad through our site via CPC and CPM models. And of course, there's very much of a standard search, browse, and all the personalization things for the users who log into to us. Powering this, we are kind of a group of engineering and combined of nationalities in Vietnam, in Malaysia, Singapore, Indonesia, Myanmar, and Thailand. And the other day, I did a capture of our GitLab that, and I realized, yeah, well, there's quite a fair number of pet projects going on there, 700-ish of the project on our Git. And yeah, I think this is the context of us as a group, and it's also the end of the so-called marketing plugs. Let's go to the actual problems in tech right now. So I guess the first part of the journey, I will share more a bit on how we started off and build up this monolith. And actually, last part is not yet linked to Go. So, sorry, hello, okay. So we start off, it was 2012, and we start really simple, actually. I think everything should be done at first very simple. It's a typical monolith code base. And our stack is standard, basically standards, right? We start off with a lot of C, C++, and a LAPP stack, which is Linux, Apache, HTTPDs. We store data on PostgreSQL, and PHP is for our webs. Obviously, back then, it's not so of interactive webs yet in Vietnam. So our main focus was to boost up the performance of the site. How we can serve the most fast with low response times, right? So we do a bit of home cook using C, C++. We build a templating engines with our own template compilers. And well, we do cook a simple search engine in C++, but largely now we switch to Elasticsearch. For transactions, we have it in C, managing mainly the worker pool that our business model is built in stock procedure, PLSQL there. Well, pretty much basics. And you see on the large left side is all the the interactive applications. It's done in PHP. Returns go through a trans server, store on the main database. Then the slave will just serve for indexings, and there's a search engine, there's a layout view of all the listings of items and stuff. Well, it started well, and I remember back then when we look at the loads of our site, one day we were so happy to look at it, it's like 0.622 seconds to actually finish all the end-to-end loads from the requests come to us and go back for the user. That's seconds, and we are super happy about that for initial setup. And well, yeah, to look at a more holistic view of it is pretty one monolithic code base. And the way we structure our codes back then is very typical, laid out by the way technical implementations, there was not much of a domain concerns on kind of boundary on that, right? And so the good part for us when we do talk a bit about how we serve our layout for the templates. So the way our template works is we have a text template with our own sort of syntax. We will turn it into C code functions, and then we will build that C function into object. We will bundle it into a dynamic link module, SO file, if those who code C. And when Apache HTTP loads up, we will just load it into the servers. So when we want to serve certain requests, we will do like catch the requests in the middle, get some of our data from search engine back, and then take the function that would render into layout back straight to the respond to the user's clients. So with this, we will see a minimal D6 actually, because we have all the layout in the actual functions, right? And the good thing is speed, but the another speed that matters to us start to slow down, which the speed for us to build new functions layout to the market, to the users. Because what happened is, as we create more and more functionalities on our site, the way our template being changed, and then whenever it changed, we need to rebuild C codes, we need to bundle it in, we need to reload the server. Unlike the traditional, or rather the more norms way of you looking at just a plain PHP, and you can load and get its real times up there, updated, right? With this, it started to tax us with something more fundamentals is that we found out our time spent on actually what we call accidental problems is more than that of the essential one that we would say. The essential one here for us means the actual functions feature for our users to buy and sell safely on our site. And the accidental problem is like things really to speed up our build. So I remember we were toys around with switching from Max to Ninja. Ninja was one of the build tools that I think Chrome was built with back then. So, well, I mean, for engineering is a good kind of problems when we deep dive, but for business as a whole, we start seeing something that's not really healthy. And well, our code base get bigger and bigger, being a monolith, and it hits certain size, and which is really, we step back and we ask, why do we need to tax ourselves with this? And it's getting really slow. This is the capture of the old repo that we have. Was mono repo is 700 megs, and you think now, for example, Kubernetes code base like 1.9 gigabyte, right? And this is like already close to half of which of that for web. It's rather hard to cope with, and the fun thing back then is that so for us, release was like a party, and we came and we have fun with each other during release times, and it's like once every week-ish or once every 2 weeks, not like a daily matter for us. Everyone was ready to roll, right? Roll back when things are really not good, and some say it's roll forward with actually new commit, just revert the old one. So we do roll forward release. Okay, so for that is really, we start to think in business sense, we need a better times to markets, and really needs to improve what we call developers UX, the experience of us as software engineers to actually build things that really matters. Because our code base evolution start to slow down to the pace of, if you look at it, if you have 0% of evolvement of your code base, then actually it's rather stay built and live in hardware and not software. Software need evolutions because it's used by us humans. And so that is the stage of where we started the journey in technicals. And in 2014, actually we start doing some step on it. And actually, the real things that we did back then was just basically decouple things practically. Because for us, as a team grow bigger in size, each of us want and need to deliver more functions. We want back then is the freedom of choice actually, and how we can autonomy runs and build new stuff. Because we see that for autonomy is in empowering our teams to actually build better things. And when we look at back, I guess this picture I snapped from one of our archive is obsolete right now. It's drawn by some guys, maybe me. In this, it looks a bit messy. And then, to be frank, back then, it was not microservice that we aim for. And I think till now, I don't think microservice should ever be an objective. It should be one of the options and the means to look at things, right? And as the start, also, there was no Golang actually. We try step multiple options. We try with Pythons, Rail even, still left with PHP. Then we switch to Nodes, and largely there's a good success with using Nodes there. Then we start to decouple things, and then we put an event messaging down to the stack. What was have there is actually what I call a polyglot kind of options for us to look at. Polyglot basically means you do with multiple programming language within your systems. Those who are not familiar with the concept and the terms. And till 2015, as our service grow, there's more things live within that. We start to kind of get another problem service and tax us on Polyglot. Is that we found out actually, well, when you do Polyglot, everyone got the flexibility, everyone happy, but there's one group of people will not be very happy. If you know what I mean, and if you are in that place, is the ops guys. Especially back then when we have not yet built a full so-called DevOps culture plus the tool chain. You'll see that there's no common foundation will tax you with multiple versions of way you can deploy things, way you can upgrade things, and it was just a nightmare. The other part also across our teams is that though we're happy with the flexibilities, but we are creating loosely couples but with very weak sort of interface designs and pre-agree sort of way we will talk to each others. And reflect back actually, this is where you create a ticking bombs in your systems. The reason is when it works very well, then one day someone will just throw out a new piece of code and it's like a trigger that explode the whole system because someone else was not works anymore, and everyone will scream. Then I guess when we look at, and this is where Go comes in the picture for us, and this is the moment up till now, it makes every one of us in the family, we call ourselves family, is really happy and never look back. The first cut that Go helped us is actually to enable us to go to a full DevOps culture, I would say, and this is where all the tool chains is built and we use is powered by Go. And my point here is I think Go and DevOps is like a childhood friends that we go hands in hands. I'll share the reason why I put this statement. So the first cut when you look at the photos is from our kind of messy initial step at the systems. The first common things that we look at as our ops will push forward is how we make it easier to deploy things right onto production. And obviously Docker is the well-known piece of everyone should be very comfortable using right now. And it's reincarnations of containerizations, but much better way of implementations for UX actually, for the engineer to use. And it's by Go, it's enabled by Go, yeah. And for the interface of it, we start to put things over on gateway patterns so that back then we also try to have many function features that go app first, which is we'll build on app. So API interfacing is a very strong thing that we need to make it right. So we picked, it was Kong versus some options, but in the end we try with a project called Tyke. Not sure if anyone here use Tyke, but it's in Go. So this is just to set the stage where Go comes in the pictures and play a big part for us. In 2016 is where we say we will go one notch further to make things really better for our DevOps and culture. This is where we are also increasing the number of features and the number of changes in the system. It was back then once every week, 2 weeks each of change. Now is we want to go really a daily business in releases. And we still stick with what we call a Polyglot microservice setup, which is basically each team should have flexibility, freedom of choice when you pick the right tools to solve your problems. But at the same time, we want all the accidental problems should go away, and the team will just focus on the logics of the features. We found out, and largely, I think this is also cited on a fair bit of articles related to microservice, is, I would say, 3 groups of big problems with these options going Polyglot. One thing is, again, repeat plumbing problems. So when I mention plumbing problem, for us here is basically you build, test, deploy, discover, and observe your service deployed on the productions. If you don't have a common foundation for that, it's actually each and every team and each every project you go out, you risk the chance of repeating solving that problem again and again and again. And without a strong engineering team to push the ops and DevOps tool chain up a notch, it's gonna be the software engineers who build feature that actually do this and solve this problem. And I think this is where goals come in largely on the set of tools we picked back then. For discovery, we use Consul. And yeah, it's powered by Go. For Dockers, and we need to schedule our containers out there, we picked Nomad back then by HashiCorp. You'll know where to come to the next step, but back then was Nomad. Then for instrumentations and make sure we can observe services and get a bit of improvement on the service performance, we use InfluxDB to store our time series there, and then visualize it through Grafana. All these are built with Golang. And then comes to the second things that I think we found in where we start decouple things is the distributed nature of microservice. It's no longer become one software on one stack of software live in one single server, but it goes to a kind of chaotic world over the networks, and failure is the norms. And then the last one is also how we tackle data. Where OL upfront is easy, but when you step data and how you define the boundary is where the actual monster comes in. But this one, it actually has not yet anything to do with what I mentioned here in DevOps. DevOps is rather the tool chain there solve our repeating plumbing problem actually. The next one that is very close to now, our Evolve, and is also powered by Go, is this full-fledged of our current stage, where in our teams we set just a simple statement that you should build it and you run it at the same time as long as you containerize it. And we evolve our stack to using Kubernetes, still Dockers. Helm is the new things for us to schedule and provisions all the operations. Then we switch over to Prometheus, another products project that is in Cloud Native Compute Foundation. The reason we switched to Prometheus, actually, by the way, Influx, we need to push things, right, to Influx, whereby this Prometheus is really go out there and grab the metrics. So it's much better handlings here when you get more and more service running. And still Grafana, and all this with Go. I think I've made my case by saying, okay, Go and DevOps is like a childhood friends, right? Let's go back to actually our own code base. So as I said, actually, our own code base, when we started off, it was something else. And then we sort of go shop around with different options. Then actually in 2016, we arrived and we stay a while with Node.js, to be frank. Largely, there's practical reasons to it, where we do have front-end webs and we speak Reacts and all this. It's go well and interchangeable when you have a back-end also use Node. But then slowly, as we build more and more service, especially at the server side, right? And we start to see the beauty of Go in actually building server-side software. And we start to see, I mean, as I think our keynote and the key strength of Go being very explicit, simple, and also you'll see the Go routine is so kind of like different chip to get it up and give us freedoms of explore with that many concurrencies models and the way we handle our high loads. We form a switch, and early of the year, this is like more of a non-written rules. We say, okay, now when you do new service, just go with Go. And all our toolings, when we build in-house, is cooked with Go. And our teams, over the years, start to evolve. And when I kind of look back, and I think, well, the beauty of this learning curve, especially with Go, is rather straightforward, actually. It's just practical. Read the docs. It's all out there. You get the binary out. You go get a tour of Go. And, well, you see the docs. You get hands dirty by some projects. And for us, with this whole DevOps tool change, we formed this kind of like on-the-prod training, so on the production training, because, well, everything is covered for you. Just put it there and feel the kicks first, and you'll see how it create the benefits for you. Then there's examples. Then I think one of the good link to look at when you get more and more toward this effective goal with all the things that we should really go through at least once, right? And for that, we move on, and when we look back, the benefit and what it impact our development workflow is largely, I would say, it's become localized and decentralized for our teams. Back then, when we do C and C++, I remember we have a kind of central servers just to make things simple in our tool chain, so everyone don't have to set up things, right? And people will go on with each of our kind of like homes and space there, and we'll build, and sometimes someone will just kind of mess up something, everyone else will scream, where's my resource? To now, we switch over to really mind your own business and just push it back via merge. And with Dockers, also a product of Go, it's enabled with something like multi-stage Docker build is quite familiar. We have own common build tools, and then once it's built, Go being all in a binary, packed to a much more lighter versions of base, and we just ship out much faster in terms of our CI/CD time compared to kind of big blocks of binary and stack. And now we start also with clients move to dApps. I think this is quite kind of commons and norms ways. We're looking at the new Go mods tools in 1.11. For the way we get up our Git is a multi-repo setup, so that we reap the whole benefits of being flexible and provide we already nail all the other interfacings and contract. And now to the actual topic that I mentioned in the subject, the journey to step the mammoth. So we do rewrite things. But with the way we start looking at and we start picking up Go, is actually it impact our way of thinking, and we look at how we refactor things. We did not just rewrite things actually. When we step out, it's largely on how we skin out this mammoth data and get a slim and kind of like lean data boundary of the things that we want to do, and then we do rewrite. Obviously, there's some that we also do kind of direct port rewrite. So on screen, I snapped some profile of one of the piece that we do largely one-to-one rewrite. The Go code is about kind of cover 80-90% of the functionality. Obviously, the old one in C and C++, we cut away all the non-use functions. It's not needed. And you'll see that actually this is really less is exponentially more like what Rob Pike wrote in his one of his blog. It's also a good piece that to read there. Is well, same functionality, 25,000 lines of code in C, and Go now is about 8,000, 1/3. I guess not just purely because of the Go difference, but obviously with the way and the simplicity of having Go help us to read through and knows what we are doing and get better grips of implementations. And that's result in the much simpler ways of approaching and implementing things. And another beauty that we look at Go is as a communities and the way we design for kind of getting the whole community to solve one problem so that we can reuse. And because of that, we largely use a lot of like convenience utils out there, and you just reuse things from other people. So when I look at a very quick look at what normally used is like there's a LAPP stack that we use. It's a good framework. Command line toolings, Cobra and Viper is quite kind of favorite things that many people use in our teams. Different way to test. I see a lot of Testify used, and obviously in terms of profiling and improve the performance of things, pprof is really a piece to be kind of look out and use more. And so I guess that is how we been through and what we look at Go as changing our way of doing things. And right now, for us at this stage, we are like, okay, we look at a cloud native sort of microservice enabling with all the cloud native infrastructure under our hoods. And what we have in our tech choice and sort of the current state of us is we still have this Polyglot service or microservice. The way for interfacing for more commons, we use mix of requests, respond, still a lot of event-driven to make things asynchronous there. RESTful still, we try some gRPC. For async is Kafka back, and we'll still have piece of Rabbit on our system. Data and data ops allow us multitudes of different options that we use. And we get some also steps at the source and ML, which actually in Go there's a very light runtime library. It's not enough to do anything, but it's allow you to run kind of like use your trained models by in Golang. Not full function though. And right, so I guess this is the premise of how Go enable and impact us. And as of now, I kind of take a quick snap at how of the system that we create. And it's really, so this is of course censored out, but it's a real life kind of a dashboard of our service. There's majority of a Golang microservice that we have, 60 plus long running. And this enables really for a small service that solves simple one problem at a time, one at a time. And it's because of that simplicity and easy to maintain the code. Things are kept greens most of the times, and we happy go solving other problems, building new more functionality instead of deep dive and kind of firefight with the reddish. And on our side, there's still Node.js and there's still Python largely for data. What we still believe in doing, pick the right tools for the job. When Go will solve the job, we'll readily use Go first. But if not, we are there to pick others. And with this, what we are cooking under our hood is more like, there's still kind of things, accidental problems that we want to solve. And right now, what cooking in-house, right, is we want to try something like GoKit internal. I'm not sure how many here have tried GoKit or IO or things. Will raise your hand. Okay, not many. Anyway, the concept is we streamline and with like a common set of package that will better helps us doing microservice in Go. And the reason we want to try something internal is because according to our stack, there's a bit difference and tweaks that we want to have. So that is just for us. And then we also try to build up some kind of end-to-end tooling, testings. And for us, our main domain obviously is to help user buy, sells safer. So we push more of our effort onto auto moderations. We can have bots. And then recently we try out with some kind of like teach the bot to do smarter stuff and put some magic onto it. And our SRE teams, there's still this continuous ones of getting better. So our gang's looking at our SRE learn Go, and then they build a bot using Go. Right now it's decent, but it's still want to become smarter. And the game and the aim is to do unmanned deployment. So like you'll just let the things roll, and you don't even need to look at it. And it's been really a great ride from the start, where you start things simple, you build it up, and then it slow down at the pace of a weekly release, or kind of like 2 weeks or monthly events for a bigger release, to a daily and to a multiple release on dailies. It's really kind of the impact that Go products, when we look at this, help us. And so I guess that is more like my sharing and the journey that we experienced. And before I left, I think we'll reflect back the way we look at Decouple, these big mammoth things, and also how Go and the mindset of coding Go and the way Go is built for us, that we built, is distilled in something is also a kind of like controversial discussions in Go and our community, is in the context. And I think the way we solve the problem is actually start really with the right context. And it should just be the context to this problem that will give us values. And then we solve one thing at a time, simple. And for each of the solution, it should just solve that simple problems, because then it goes to another microservice, another simpler source base. And so my thinking, and this is purely my opinions, in if you handle this context, and you can do a lot of things with these values. And really, if you black hole this context, as in you suck everything that can put on this value, the value will create a mixture of unknowns, and you don't know which problems to solve, and it easily get bloated out as the final products. So yep, that is my sharing and thoughts. If you want just go, we are hiring as well. Yeah, of course, this is a plug, careers.com, and we are spanning across Vietnam, Malaysia, groups holding in Singapore, and we are fully owned by Telenor, our grandmother company. Thank you.
Here you are.
Okay, number one, yes, full stop. It's quite straightforward, because really, if you look at, this is a true story. Even 4 years ago, back then when I started, right? Then we were trying to. There was a lady, great candidate. She was very, and we were very close down to let's work together. And she backed off because she was back then optimizing compiler, I think with HP or something. And for us, those we do C, but we do web page and things to render layout. And she was like, what? With that? So she was like, okay, no. My point is right now, I think even get people excited in C compared to Go, and we'll see our community grow this fast. So if you pick the first choice, it's easily Go. Still using type? Actually, no. We moved to Kong actually. So multitude of reasons, but I think 3 or 2 years ago we actually moved off type. We started up Tide when Tide was very early in the stage. Back then, Kong was there already, but yeah, it's just that Tide in Go and Kong is not. So we are like always want to tinker with things that we use. So it was options. Okay, what Go kit for streaming better than gRPC? To be frank, I think let's talk about the streaming part and gRPC. This is pure my thought. We use a service in gRPC, not so much. One true experience is that then when we have this transaction server existingly built in C and we want to have other components that talks to it, and it has its own RPC and set of commands over TCP. And we was thinking, okay, let's put gRPC on, and this server should not talk gRPC and go with the others, more client used to it. After a while trying, then our guys was sharing with me that it's actually not a good choice because it's the existing code and then the new clients, you put the things in between, then actually extending the new stuff and then maintaining the backward compatible of the old stuff is heavy for us. And when we look at this, it's like really, it's end of the day, it's a request, right? It's request response for us. Now streaming, I think it's sort of on another kind of domain to discuss about, to be frank. So when we compare things, that is a bit not really apple to apple to my point of view actually. So why you create own push node can reuse other? All right, I guess this is one of the photos that we before, right? Now we don't actually kind of build push offline push node. We use Google, of course, out there. Back then, the part we have there is actually the WebSocket push that we built. Is more like so we have a need to actually sell a bumps and people buy it via an SMS push to our third-party SMS system, and that will notify our backends. We want the user on the web to just see that, okay, when this SMS goes in and it's instantly acknowledged in our system, so we decided to have a push out. So that is the pusher that we have there. It's not offline push notification per se. Okay, lesson. Where are we now? Okay, lesson learned for other teams to migrate to Go. Okay, I think this is back to the value that I sort of still out to my last slide. That's, I think we should first look at the problems and the context of that problem that we are solving. And then we'll see how Go will solve the problems. And not just a complete direct rewrite and trying to replicate what is already built there in the code, because there's some way and some particular way that the old code was built. And for Go, it's like sometimes you have a paradigm shift in terms of where you're handling it. Okay, how many questions left do we?
Yeah, because we're running out of time, so you choose
okay.
Only one question. Choose one.
So, any question that we should? Is the lack of growth framework, when do we consider Golang? Okay, I'm not gonna answer this. I know that.
Yeah, okay.
Yeah, from the gang, right? Is the lack of Go framework for web development compared to other languages slow? Well, I mean, you see that our code base, actually there's 30% left of Node.js. You know where it's come from, actually. So our web and, so our front end is React, right? And we actually still do it quite often. us to be frank from the actual problems and the stack of the community that provide us, that still very much better in terms of speed to develop different, especially web and universal web app components. For Go, yeah, we use it more for our backend of services. And for those like the transaction server that we kind of switch and migrate to Go, and that give great value. So yeah, I think it might be the lack of Go web framework, but my point is still we should use the right tool for the jobs. And that is also the way, I mean, Go is initially, I think, we'll keep it simple. I mean, really less is much more that we can have. Okay, I think that should be the last questions.
Okay.
If any.
So there's no question, right?
Any
question?
Last question from the
auditorium. Last question.
I forgot my question actually.
I'm just covering up for him. Yeah. So,
okay.
so most of your asynchronous systems, do you write those in Go as well?
Sorry?
Your asynchronous systems like queues, background workers, are they written in Go as well? And how do you manage them?
Okay, so I know where this come from. So we have Kafka and RabbitMQ. Some of the worker back then was still in Pythons. Kafka and Pythons, there's initial. There's some that we actually, yeah, we cook in-house a library that is it's like K-stream in Java, right? And Kafka, but we use Go. But it's still really very much of an early stage. The problem when the back end and the streamings, and especially when you want exactly once and like a transaction, distributed transaction, is like I think from my point of view, we should stay clear away from solving that until you have to solve it, right? It distributed transaction. But in Go, a particular usage of that was in our auto moderations. So we put a trained neural net in, and we use Go binding to actually run it. And for that, it fits some event out of Kafka. So we sort of utilize the middle layers. The events there is serialized using Avro, and then use LinkedIn, and also kind of like I think Sarama kind of to actually use and talk with Kafka. Then we put some of our own home cooked things to handle the provisioning, the discovery, the metric instrument things, and it goes through. This, to be frank, when we look at that area, the light in Java, for example, is much more mature compared to what we have in Go. We're having kind of like still very initial step and trying to solve that problems, but not fully. Okay, I guess my time is up, and thank you for everyone for question.
Okay. Thank you for the time.